Hello and welcome to Lesson 9 of the UNIDO SPX programme, Production Control Systems. In this lesson, we will look at the main production control systems in use in business today. These are make-to-order, Kanban, and a rate-based scheduling system. The main reason for the use of these different systems are to manage stock levels within an operation. The choice of system depends very much on the demand from your customer, on the type of product you are manufacturing, on the volumes of product you are manufacturing, and on the complexity of the product that you are manufacturing. In today's world, the ideas that have been used in manufacturing are now also being used in the software and service sectors to also provide a balanced approach to the use of resources to deliver to customer requirements and demands. Main production control systems. In this graphic, we try to demonstrate when the different types of production control systems are most appropriate. If we start with make-to-order, you will see that a make-to-order system is most useful where the product is highly unique and where the production control volumes are not high, where they might be low. Make-to-order means that products are made specifically for a customer. So product uniqueness is an important factor. Where volumes are very high and uniqueness is low, a rate-based scheduling system is seen to be more appropriate to the needs of the customer and the needs of your business. And in the middle ground, the use of Kanban system is quite appropriate. In some of the more advanced manufacturing facilities today, they have managed to bridge, sometimes using Kanban, into rate-based scheduling area, and sometimes using Kanban into the make-to-order area. And we will talk about how this process is useful and suitable in those particular instances. But in general, if your product uniqueness is high and your volumes are low, a make-to-order system is the most appropriate. If your volumes are high and your uniqueness is low, rate-based scheduling is the most appropriate. And in the middle ground, Kanban can be very helpful and appropriate. It is important to be aware, however, that the system of production chosen can and often will change over the life cycle of a product. At the early introductory stages of a product, the launch phase, when sales volumes are low, a make-to-order MTO system is often the most appropriate. There might not be enough perceived market to invest in high levels of automation, and maybe it's not clear will the product actually grow in volume over time. As the product is launched into the market, it's probably possible that a Kanban system would become more appropriate to your manufacturing cycle. In the mature phase, rate-based scheduling. The product has now reached a level of market acceptance. There is a volume requirement for the product, and there is seen to be a period of time where the volumes will be consistent. So it's probably possible to invest in the systems to produce to a standard rate. As the product moves towards the end of its life cycle, into a stagnation phase, it's probably more appropriate to use Kanban, to stop using the high level of resources and to rebalance your efforts once again to ensure that your productive capacity meets the market requirement and the market demand. And in the last phases of the product's life cycle, maybe it will return to make-to-order. At this point in time, it would be important for a business to ask themselves, should they just stop making the product completely? But if their customer demands and there is a value to be achieved for the business, it's possible to revert back to a make-to-order. The point about the graphic is to show you that over the life cycle of a product, the appropriate manufacturing system may change. Make-to-order. In the next segment, we will look at the concept of make-to-order and how it is appropriate for particular types of products and particular types of manufacturing facilities. The make-to-order is ideal for unique products or low-volume products. By unique products, one-off products, special machines, situations where a customer has specific requirements that will unlikely to be repeated in significant volumes, or products that will never ever reach high volume production levels. In some of the major Japanese factories that I have visited, you will often find a combination of make-to-order, Kanban and rate-based scheduling, dependent upon the actual consumer usage and demands for individual products. Many years ago, I visited Sony in their video recording facility. And some of their products, particularly the more high-end cameras designed for commercial activity, were made in a make-to-order grouping in a cell. While their commercial for the normal consumer cameras were made in a high production facility. And the middle ground was using Kanban systems to control the production. But make-to-order is ideal for unique products or for low volume products. Because the volumes are low or even unique, little or no stock of finished goods is held. The customer understands that they will not be achieving deliveries from stock, that in actual fact the product will be made for them from scratch. Typically, because an area of the factory can be dedicated to this facility, the response times of the company to start the production process will lead to short response times. Not necessarily short delivery times, because certain parts and components may need to be ordered, but we will address this question in a moment. But the response to start a production can be quick. The fact that there is no levels of stock held, that it is a small dedicated area or a function of the facility, means that that particular group can be highly flexible. The customer working with the supplier in a partnership arrangement can actually discuss flexibility, can discuss how they can work together, to achieve the overall objective of meeting the customer's needs. But in a make-to-order environment, obviously the importance of a good supply chain becomes critical. If you need your suppliers to deliver to you key parts and components, you should spend some time working with them to build their capacity and their capability so that between the two of you, between your group of suppliers and yourself, you can actually deliver products on time to the customers at the proper level. This simple photograph gives an example of a make-to-order environment. Each of the white panels refers to a specific job being manufactured in a make-to-order area. On the photograph, you can see descriptions of key components for an area to manufacture a product. In the middle photograph, you can see clearly the ticks. The team leader supervisor has been able to ensure that the parts and components to manufacture these products are available to his staff in the make-to-order area. When the parts have been ticked, he knows he is in a position to ask his staff to manufacture the product. On the page on the right-hand side, you may notice that there are no tick marks on the sheet, which helps the team leader supervisor realize what he has to bring together in the parts and components to facilitate his staff to make the product. This is an example of visual measures being used in a make-to-order environment. One of the issues that you can well imagine in the make-to-order concept is to have parts available so that a particular product can be produced for the customer's requirements. In this context, it is very helpful if standard components can be used in creative ways to deliver additional functionality for the customer. If every part has to be made from first principle, from raw material, it can delay the delivery process significantly. It is much more helpful if it's possible to configure standard components to customer needs. So if it's possible to configure to customer needs, lead times and delivery times can be shortened significantly. One of the most successful companies in this context comes from Japan and would be the company called Casio, where they have a very extensive range of calculators. However, within the calculator body, they use a series of standardized components to allow them to configure the product to meet the customer needs without having to have an excessive level of individual circuit boards for their products. On some of their products, the initial circuit board would have much higher functionality than the customer has bought, but the functionality would not be enabled, therefore allowing the company to hold small numbers of circuit boards while providing large levels of customer-specific configured products to the marketplace. In the make-to-order environment, match production directly to customer demands. We are not forecasting, we are not holding stock, we are actually producing to the requirements of the customer. We are actually matching our production directly to their customer needs. In this way, we effectively minimize the waste, minimize the costs, minimize the holding of stock and the delay of time. Products are only manufactured when an order is received. We are not producing stock items. We are ready and willing to manufacture on receipt of a customer order directly from the customer. This in turn means that the customer needs to be in partnership with us to ensure that we understand some visibility of their needs and can have resources available as and when they need them. An important point to remember about the make-to-order system is that there is very low risk of obsolescence. No to low risk of obsolescence. If we are not holding stock of finished goods, it is impossible that the finished good would go obsolete because it does not exist. There is no stock holding. And this can be very helpful when it comes to the end of the year, the end of the financial period, where there is no obsolete stock to be handled with. But it also puts a pressure on you, on the producer, to work closely with your supply chain to ensure that your supply chain also can have limited, if any stock, if no stock, so that they don't end up with obsolete stock in their systems. Once again, this photograph helps, we hope, to explain to you how the delivery of components and parts in a make-to-order system can be accomplished. This panel is a trolley on wheels. Each morning, the materials delivery facility will fill these boxes with the parts and components required for today's production in the make-to-order area. This avoids the holding of parts and components in the production area because they're not needed. Each morning, the stores area will deliver what is needed for the day to the make-to-order area. We call it the milk run, that we're delivering milk out to the facility each morning. So the parts are delivered for what is needed for that day's production and not for stocking parts in the production area. There are some examples of make-to-order production that we are possibly very aware of. Dell computers are well known for making what a customer wants. They don't have stock, they don't make to stock, but they actually will make a computer, or should I say configure a computer, to your needs. They have standard components which they will bring together in a special way suited to the needs of their individual customers. In this way, a customer can actually order the different parts that they feel they want for their particular computer. Dell obviously constrict the palette, the choices that are available, to ones that they believe will be appropriate for the vast majority of their customer base. In their commercial sales, they can configure computers directly to mass buyers. But as a consumer, as an individual buyer, it is possible for any person to go and order a computer that they feel meets their needs. If you get a chance to visit the Dell facility, you will realize that they actually do configure the computers to your needs. But they have developed a very capable supply base and also a very capable logistics base. Their supply base can deliver to them the key components required to manufacture the computers, to assemble them and to configure them. But they also use external logistics people who can take care of the keyboards, the ancillaries, the screens, the power supplies, that in turn will bring the base computer unit into a computer that is suitable for us, for our use in our homes or in our businesses. So they have worked very strongly to develop a make-to-order production capacity and capability, but also focusing very clearly on the development of their supply chain and their partners, their logistics partners. We have experience of Dell in Ireland for many years now, and when they came first, they used trucking companies purely to ship their boxes, to move the computers post-production. Many of those logistics companies have evolved into fully integrated logistics companies that support Dell in their delivery of personally configured computers to individual consumers. The second example of make-to-order that we are probably very aware of is that of the McDonald's restaurant. In McDonald's, an individual goes and orders their burger, orders their food. McDonald's will make it for you. If we look at Burger King will make it specifically for you and make a strategic point that they will make a burger specifically to your needs. But in this environment, we do not see large amounts of stock in position, waiting for customers to arrive. Typically, there is maybe one piece, maybe no pieces that are in stock waiting for the customers. Most typically, you will enter a restaurant, order your food, and it will be prepared for you. I mentioned Casio earlier on, probably one of the most vibrant examples of what is known as mass customization or make-to-order on a global scale. By being creative with their design of their products, their configuration of their products, and their manufacturing capacity, they were able to make to order a very wide range of products specifically to customer demand coming from the marketplace. And the fourth example I would share with you of make-to-order production is that of Sony. I mentioned in the Sony facility, they blended make-to-order Kanban production and rate-based production. I will deal at this point with the make-to-order operation. For the high-value, low-volume products, high-specificity products, they had created a simple cell where individual cameras would be made for individual customers, so that they could match their production capacity to their customers' requirements, to provide to customers the camera with the configuration, with the capabilities that the individual customers wanted and were prepared to pay for. A key point in make-to-order is that because we are providing so closely to the end customer's needs and requirements, and quite often adding significant value to the product by tailoring it and making it very specifically to end users and consumers, it is quite often possible to discuss a premium with the customer for that level of service. So make-to-order can be helpful for you and your business in minimizing your stock holdings. It can be a challenge to you in optimizing your capabilities and also optimizing your supply chain, but it can also be a positive in terms of revenue generation and value retention, provided you have developed your systems to be able to optimize that aspect of the production facility. Kanban. We will now talk about Kanban and the Kanban system. From the earlier graphic, it was clear to us that Kanban is suited to medium volume, medium diversity production. It's typically known as the 2-bin system, and I will explain this as we go along. Suited to medium volume, medium diversity production. But once again, designed and created to provide a very positive link between customer demand and productive capacity. It is designed to provide a highly visual system whereby materials can be available constantly, where needed, when needed, as needed. It provides a system where the volumes of raw materials are strictly controlled and where the non-availability of materials is very visible. Products are called down based on consumption. The Kanban system links individual elements of a production facility to a consumer based on demand. Kanban cards contain all the information required to order production of an item. When we talk about here calling down products based on demand, I have had the opportunity to visit many factories. One of the most interesting factories is the Toyota engine factory. In the Toyota engine factory, they use Kanbans from the car assembly plant to order engines. And the simple Kanban card that is produced and delivered to the engine factory tells the engine factory what type of engine, what quantity of engine is required at any given time. The whole factory is worked on a Kanban system where parts and components right back to the casting stage are delivered to the next step and stage in the production operation based on a simple Kanban, a visual indicator. In Japanese, Kanban means a visible sign, an indicator. It used to relate to the sign for a shop, so you could see which shop is a restaurant, which shop is a wood shop, which shop is a metal shop. It was a visual indicator to say something was necessary or something was needed. In the manufacturing facility, the opportunity now comes to have information from one part of a process to the next part of a process. And when upstream a consumer wants to buy a car, the car manufacturer can call for the particular type of engine to the engine facility, who in turn will call to their casting and machining facilities to provide the components to allow that engine to be assembled. Very simply, very easily, the materials will flow from downstream to upstream based on upstream demand, based on upstream consumption, not based on a forecast, not based on somebody's opinion, but based on usage. The system is highly visual. In this particular graphic, the cards in the little plastic wallets would be regarded as an individual Kanban. If you notice green, yellow and red, this graphic gives you the opportunity to see how it's possible to visualize where the priorities are in any manufacturing facility. In this case, we can see that the number of Kanbans in the first column has now touched into the red zone. So as the manufacturing manager responsible for this production, I can see I need to focus on making these parts next so that I can deliver my supplies to my upstream customer. I don't have to worry about these products because they are still in the green. I need to be concerned about these and these, but not this, this or this. So this one panel allows me to see very quickly and easily which parts need to be manufactured next, which area needs service next, which areas I do not need to worry about at the moment, and where I should focus my attention and my people's attention to deliver to my customers, our upstream customers. This provides me, as the manager of the area, and you, if you adopt a Kanban system, an opportunity to visually see where your pressure points are, to visually see where you need to provide some additional focus or energy, or how you can prioritize your work and your people's efforts for that period of work time. We talk about Kanban as being a two-bin system, but it can be a bin, a bucket, a silo, a place on the floor. The two-bin system is a way to describe how the process works. If you imagine in your own domestic environment at home, if you drink tea, you might always want to have tea bags or tea in the house. So you start working from one packet of tea. You would probably want to have a reserve packet so that when the first packet was empty, you could take out the second packet and still be able to enjoy your tea. And the Kanban system operates in a similar way to say, we will not run out. Our assembly people, our production people, our consumers will always have access to some volume so that they will not run out, so they will have activity. So a Kanban can be a bin, a bucket, a silo, and I will show you some examples of this as we go forward. The Kanban helps you manage stock and production. By controlling the size of the Kanban, the quantity of parts in the bin, it's possible to actually manage your stock levels. Some people, when they introduce Kanban system, will try to find the least amount of parts and components possible to minimize the stock levels. I would suggest to you, it is better to have slightly more subcomponents and parts than have too few. So as you move to introduce Kanban into your operations, I would suggest you keep a little bit extra in your Kanban, in your one bin and second bin, to ensure that you do not run out, so that the system does not collapse as you begin to learn how to use it. As you get comfortable, as you get experience in using the Kanban system, it is possible to reduce the volume in the bins. It is possible to minimize the stock and drive towards least amount of stock in your production. I believe that the Kanban can be very helpful because it can be very visible. If you imagine the difficulty of trying to remember all the parts and components, the bits and pieces that you and your people need to do your jobs on a daily basis, it's very hard to remember everything. The Kanban system allows you to put in place a management system once, and it then manages itself. From there forward, it manages itself. The only management you need after that is to find ways to minimize the quantities in the Kanban, to develop the capabilities of your suppliers and your downstream supply operations so that you can safely, without risk to the operation, minimize the quantity in the Kanbans. We will now look at some examples of actual practical Kanbans. In this example, the gentleman is holding a Kanban card. The Kanban card relates to these two bins of machined metal parts. The two bins hold the same type of part. This card has come from this bin. On the card will be all the information of what the part number is, the quantity, the details of the machining, the suppliers, the details to enable him and his parts people to manage that stock. At the moment, they are working, taking parts from the bin on the left-hand side. When this bin goes empty, the materials person will take the card and reorder these parts. So this bin has now gone empty, so the production facility can remove parts from this bin and continue their production without having to stop. When the Kanban parts have been replenished, they will refill this bin and the card will go back into the bin. In this way, the facility never runs out of parts. You may think that there are too many parts in these two bins, and maybe there are. But at least they have now got a control system in place that when these parts are used, more parts will be ordered. Obviously, you have to be aware as the parts manager if a component is no longer going to be used. And in that instance, you will know to not replenish the parts into that situation. This is an example of small parts, easily managed parts, quite easily lifted. In our next example, you will see parts that are heavier and bigger. And they're in what we would classify as a bucket as opposed to a bin. On the bucket, again, you will see the detail of the part number, where it goes, quantities, etc. These parts are heavier, and to make it easier for the work person to move them, they were actually put into a bin. And if you look closely, you will see the bin is actually on wheels. This idea was created in an Irish company, and this piece of metal here is a handle that can be lifted up, clipped into position to allow these heavy parts to be moved easily to the point of use. So the company has, number one, decided to adopt a Kanban system, has understood that some of their parts are bigger and heavier than others, and has thought about a creative way to be able to deliver the parts to the point of use in a simple and effective way without using up too much space. If I draw your attention to these two carts, you will see these two carts have the same part in them. Once again, the Kanban is on the cart. You will notice this is half empty, this one is full. You might ask, where is this cart? This cart is now off being refinished, replenished, refilled with parts, while the assembly people are working from this cart here. This bin that is missing, using an Irishism, the bin that is not here is off being refilled, while the workers in the assembly area are working from this cart. I hope this gives you an example of two types of Kanban. Rate-based scheduling. Rate-based scheduling is best suited to mature products. Products where the volumes are large. Products where the marketplace for the products has been defined and is clear and is significant. Production is typically based on forecast. Because the market is secure, because the product is stable, it is probably easy to forecast demands and requirements. So on this system, we are not talking about immature products. We are not talking about grossly specific products. We are talking about stable products where the markets are stable, the product design is stable, where it is possible to invest in capital equipment to be able to make a consistent level of product over a consistent period of time. It is clear that accurate forecasts are helpful. So forecast accuracy helps manage stock levels. If the forecasts are inaccurate, stock levels will not be good. Accuracy helps the production facility to make what is required at the time in the quantity that is needed. This means there should be good communication between the salespeople and the manufacturing and the purchasing and the production planning people. In a mature environment, because there is a stable market and a stable demand for the product, stock provides some stability for production. Production does not have to respond to the daily drawdowns from the marketplace, because one day maybe more product would be consumed by the consumer than a second day or a third day. But because in general the market is steady, it's possible for production to stabilize their outputs to meet the requirements of the market on a steadier basis. It provides some degree of comfort to the manufacturing team that they can actually produce in a consistent way without having to immediately respond to the slightest variation in the market demand. Once again, however, it's important that good communication exists between the sales team, the planning team and the production team, so that if the sales team think there will be a reduction that will be more consistent, that they talk to the production team so the production can reduce their output to meet and to be in line with the revised market demand. In the earlier graphic where I showed you the life cycle of a product, it looked very simple and very straightforward. However, that demands good communication between the sales, marketing, production planning and production people to optimize stock availability and cash utilization in the business. The level of automation used and applied in a rate-based scheduling system depends on the volumes required. So the level of automation depends on the volume of product required. If it's going to be a high volume, if it's going to be a long-running product, it's probably worth your while to look at automation. How can you invest in process improvements in equipment and machinery to deliver volumes effectively and efficiently? Typically, we're talking about mass production or process industry. At this point in time, it's possible to invest the capital sums to deliver the product at the volume required by the market. But I would suggest to you, as a small to medium-sized company, it's often possible to look at sub-automation. Not full automation or full dedicated production facilities, but to ask, is it possible using the creativity of you, your people, your equipment suppliers, your engineers, to find ways to enhance simple machinery to approach towards mass production capabilities. If you ever get the chance, visit Jönköping in Sweden, the Husqvarna factory, and you will see a fully automated machine that was built in the 1850s, 1870s to produce using leather belt driven machinery producing mass production items. So it does not have to be very advanced and technologically advanced, but it does require creativity and thoughtfulness to find ways to achieve high levels of productivity. Managing stock levels. It's important that we realize that the production systems we're talking about are all designed to give an optimum supply to the market while giving an optimum supply and demand for cash to your business. Stock is cash. We talked about obsolescence. We talked about the possibility of parts becoming obsolete or out of date. If they do so, they are worthless. They lose their value very, very quickly. So it's important that we focus on stock levels and find an appropriate production system to minimize the stock and cash requirement for your business. Managing stock levels means about being able to need to supply to customer. We want stock so that we can supply to our customers. We don't want stock just for the sake of holding stock. We want to turn materials and components into cash quickly. We need to be able to supply our customer at a minimum cash and stock level. If time is money and stock is cash, we need to find ways to be able to turn our raw materials, our components into cash quickly by supplying to our customers. So the three systems of make to order, Kanban and rate-based scheduling provide a basis to be able to find an optimum situation for you and your customers in today's circumstances to meet this minimum cash and stock level requirement. It's not good to have lots of stock, but it's not good either not to deliver to your customer as they need it. I'm going to talk about point A, under minimum level but customer serviced, and point B, over maximum level following production reduced, on the next graphic. If we look at our demands for our marketplace over a year, our stock level over time, we set a minimum stock level that we hope to have in stock and a maximum stock level that we hope not to exceed. Over the year, sometimes our customer demand will be higher and our stock will go low. Sometimes our customer demand will be low and we will have excess stock. We are trying, as a business, to keep ourselves between our max and minimum stock while always being able to service our customer. If our customer is comfortable and happy that we can service their needs, it is a key factor to them in continuing to do business with us, and in turn gives us a stronger partnership relationship, which is one of the key elements of the UNIDO SPX system. This lesson has tried to give you an early introduction to stock control, production control systems. If you look at the website, you will receive further information. Thank you very much.
Hello, I'm Homer Kraut. We're going to spend the next few minutes talking about world-class business and tools for saving time. We'll take a look at time as a resource, toolbox and shadow board systems. We'll spend a few minutes talking about early warning systems. We'll discuss task flow, and then we'll look at some additional measures that you can use for saving time. First, time is a resource. This is an easy issue to overlook as you begin working on a project or you're working in a business, and it's an area that's most critical as you move towards the completion of a particular product.